Hello, this is Mr. No, and today we will be doing multiplication and division with scientific notation. Hashtag the title, scientific notation just got harder. This is a bit more tricky and requires more math skills. So right now, right there is the multiplication and division. We'll also in this video be having addition and subtraction. Our first situation, our first situation is 8.4 times 10 to the power of 2 times 2.5 times 10 to the power of 6. So what you would do is you time 8 times 8.4 times 2.5, and then you would have times 10 to the power of 8. How I got 10 to the power of 8? I just added the exponents of 2 and 6, and then we have 10's the same, so we have 10 to the power of 8. With scientific notation, it will always have 10, no other number. So you have, if you do 8.4 times 2.5, you should get 21, and if you times that by 8, you could write that down, but that's not scientific notation. Reason being, the number is greater than 10. Sorry, greater than 9, because it has to be less than 10. So if you have 2 point, then you have to add a decimal point between the two digits. You should get 2.1 times 10 with the power of 9. I understand that looks like 109, but it's 10 to the power of 9. But I'm pretty sure if your teacher wants you to write in scientific notation, you write it 2.1 times 10 to the power of 9. Or if you can, you can also write the bigger weighted number that I don't even know how to pronounce. So we have our second example here is 2.63 times 10 to the power of 4 times 1.2 times 10 to the negative power of 3. So you would do 2.63 times 1.2, and then you would multiply it with 10 to the power of 1. How I figured this out, we add the exponents. Negative 3 plus 4 should equal 1, so 10 to the power of 1. So 3.156 times 10 to the power of 1, or you could write 31.56. Now I will move on to addition and subtraction. Alright, so this is addition and subtraction with scientific notation. Our first example, 6.89 times 10 to the power of 4 plus 9.24 times 10 to the power of 5. You would do 6.89 plus 92.4, and then you will multiply that by 10 to the power of 4. Now how did I get that? Because you know that 10 to the power of 4 and 10 to the power of 5, if you add their exponents, it's 9 but not 4. And how did I get 92.4? Well, if you go on to 9.24 times 10 to the power of 5, you move the decimal point one place to the right, you should get 92.4 times 10 to the power of 4. In addition, it's always good to keep your exponents the same, that way you can use it. So you would have 10.4, 10.4, which would equal 10.4. So 6.89 plus 92.4 times 10.4. Then you would do 99.29, because that's 6.89 plus 92.4 times 10.4. You can't do that because it's the number of 99.29 is bigger than 9 and not less than 10. So you remove the decimal point one place to the left, and you should get 9.929 times 10 over the 10 with the power of 5, or 992,900. So our next situation is 7.83 times 10 to the power of 8. You're subtracting that from 11,910,000. So you would convert that into scientific notation. So 7.83 times 10 to the power of 8 minus 1.161 times 10 to the power of 7. How I did that? I moved my decimal point all the way to the 10 million right here, and then I will get 1.1610. I'm sorry, 1.61. You don't need to add the zeros. And then if you would count, that's movement of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's 7 times you move the decimal point, so your exponent is 7. Then you would do 7.83 minus 0.1161 and you would get times 10 to the power of 8. Now how did I get 0.1161? It's because I once again moved the decimal point one place to the left to make the exponent higher of 8, and then I would get times 8. Then you would have, if you subtract, you would get 7.7139 times 10 to the power 8, or you could write 771,390,000. So that is scientific notation for you. Have any questions? Please leave it in the comments below.